Right now, the Caribbean is still absorbing the aftermath of the deadliest earthquake Venezuela has recorded in over a century, and the ground has not stopped moving since. On the 24th of June, two massive earthquakes struck within 37 seconds of each other in northwestern Venezuela, and the confirmed death toll has since climbed past 6,400 people, with tens of thousands still unaccounted for. 780 kilometers away in Trinidad, almost nobody felt it. And yet within days, a section of Trinidad's own coastline had risen 20 feet into the air. A road had been torn in two and shifted sideways, and a brand new island of mud had risen out of the sea. Weeks later, on the 20th of July, new shaking hit the region again, two separate earthquakes north of Tobago and northwest of Trinidad, and one of them struck a patch of ocean floor so quiet that fewer than 100 earthquakes had ever been recorded there in the entire instrumental record. Scientists have identified this exact stretch of plate boundary as locked, meaning stress has been building rather than releasing for years, and theoretically capable of producing a magnitude 8 earthquake. So is it finally letting go? This is the full detailed story of what has actually been happening beneath the Eastern Caribbean this summer, what the seismic data actually shows, and what scientists are and are not able to say about what comes next. No hype, no exaggeration, just what the data actually shows. Drop a comment and tell me if you felt any of this yourself, because I read every one of these. If you want grounded science coverage instead of panic headlines, subscribe. It is free. And a like helps this reach people who need to understand this before the next one hits. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand everything that has happened since, you have to start with the 24th of June itself, because it set every other piece of this story in motion. At 4 minutes and 34 seconds past 6 in the evening local time, a magnitude 7.2 earthquake ruptured 27 kilometers beneath Yaracuy State in northwestern Venezuela. 37 seconds later, before the first quake's seismic waves had even cleared the coastline, a second earthquake broke on an adjacent segment of the same fault, just 13 kilometers away and only 10 kilometers deep. This one a magnitude 7.5. Seismologists call two great earthquakes rupturing in immediate succession on neighboring fault segments a doublet, a genuinely rare feature even in one of the most seismically active regions on the planet. Together, they became the strongest earthquake Venezuela has recorded since 1900. The worst damage fell roughly 160 kilometers east of the epicenters in Caracas and along the El Guaira coast, where a reported 80% of buildings collapsed. As of the most recent tallies in mid-August, more than 6,400 people have been confirmed dead, with roughly 86,000 injured or hospitalized and tens of thousands still missing. The United States Geological Survey's own automated damage and casualty modeling system had warned early on that the final toll could climb considerably higher, potentially past 10,000, and issued its highest possible alert level for both loss of life and economic damage. The United Nations has estimated the earthquake affected up to 6.8 million people and caused approximately $37 billion in damage. The rupture itself was a right lateral strike slip event, meaning the two sides of the fault ground horizontally passed each other along a nearly vertical plane on the San Sebastian segment of what geologists call the Bocono, San Sebastian, and El Pilar fault system. This is the critical detail for understanding everything that follows, because that fault system is not a short, contained feature. It runs for more than 1,900 kilometers from the Venezuelan Andes all the way to the eastern edge of the country, accommodating the Caribbean plate's slow eastward slide past the South American plate at roughly 10 millimeters a year. And it does not stop at Venezuela's coastline. Slip is transferred further east through the Los Bajos fault and onto the Warm Springs fault, which runs directly across the Gulf of Paria and into southwestern Trinidad itself. In other words, the same crack in the earth that killed thousands of people in Caracas runs, in a geological sense, straight to Trinidad's front door. What happened next in Trinidad is genuinely one of the more remarkable pieces of this entire story, because almost nobody there felt anything resembling an earthquake at all. The United States Geological Survey's public felt report system collected more than 700 responses to this earthquake from across Venezuela, Colombia, the ABC Islands, Puerto Rico, Brazil, and as far away as Bolivia and Peru. Not one came from Trinidad and Tobago. And yet, within days, geologists arriving at Galfa Point on Trinidad's southwestern peninsula found a stretch of beach that would normally sit flat had been uplifted by as much as 20 feet, with the coastline itself shifted out to sea by at least 100 feet. Xavier Moonen, the geologist who led the initial site visit for touchstone exploration, described the uplift as having happened essentially instantaneously based on the large numbers of marine creatures trapped and killed by the sudden rise, including what appeared to be a stingray crushed beneath an uplifted boulder with no apparent time to escape. 2.5 kilometers to the west, at a community called L'Envieuse, a fault tore straight across, a residential road, and by matching features on either side of the break, Moonen measured roughly 2 meters of lateral ground movement, meaning every home and every piece of land east of that line had shifted as a single solid block. Along the same stretch of coast, Trinidad's Columbus mud volcano, dormant just days earlier, erupted fresh mud. Across more than an acre of new ground, and a completely new, temporary island of extruded mud material rose roughly 12 feet above the seabed, a few kilometers further along the coast, eroding away within days of forming. The reason distance did not save Trinidad from any of this comes down to a genuinely counterintuitive piece of seismology, and it is worth understanding because it reframes what far away actually means during an earthquake. Seismic waves do not simply shrink uniformly as they travel. The Earth absorbs high-frequency, sharp, fast-moving energy far more quickly than it absorbs low-frequency, slow-rolling energy. By the time a wave has traveled 780 kilometers, the sharp jolt capable of damaging a building has been filtered out almost entirely, while a long, slow sway with a period of many seconds can travel on largely intact. At the one seismometer in Trinidad that captured the full event in public, usable detail, a citizen-operated Raspberry Shake station in north-central Trinidad, the numbers made this precisely clear. 99% of the earthquake's energy arrived below 0.3 hertz, with a dominant period of about 17 seconds, and that slow, deep swing continued for a genuinely remarkable 13.5 minutes. Peak ground acceleration, the measurement tied most closely to building damage, was just 0.004 times the force of gravity, essentially nothing. But the ground kept slowly rolling for so long that water in ponds and swimming pools across southern and central Trinidad began sloshing over their banks with no wind blowing at all, a phenomenon called a seismic seiche, the exact same physics as coffee slopping out of a mug carried at just the wrong rhythm. Compared against a small, genuinely local magnitude 4 earthquake that struck Trinidad on the very same afternoon, the Venezuela doublet was only about 5 times stronger in the frequency band people actually feel, in the slow, deep band that moves water-saturated ground and shakes tall buildings. It was roughly 1,400 times larger. That distinction matters enormously for understanding why Galfa Point specifically failed the way it did. The University of the West Indies Seismic Research Center's preliminary investigation found that the ground beneath the L'Envieuse mud volcano site has a natural vibration frequency of about 0.036 hertz, one full swing every 28 seconds. The waves arriving from Venezuela had a dominant frequency, almost exactly twice that fast, one crest every 14 seconds, meaning every second wave crest arrived precisely in step, with the ground's own natural rhythm, pumping energy into the site continuously for 13.5 minutes rather than delivering one sharp, brief jolt. The Seismic Research Center concluded the local mud volcano system had effectively resonated with the distant earthquake's energy, reactivating mud flows and destabilizing already water-saturated, fault-riddled ground. Moonen has drawn a direct comparison to a similar 2018 landslide event at Los Iros, on Trinidad's south coast, where the ground did not stabilize afterward, but instead kept slipping, eventually moving 3 to 4 times its original displacement over the following 7 years. His assessment for the newly faulted ground at L'Envieuse is that further slippage there is essentially inevitable, even if it can be slowed by managing vegetation and rainwater infiltration along the fault zone. Following the doublet itself, the United States Geological Survey issued a formal aftershock forecast, and it is worth being precise about exactly what it said, because it draws a clear, evidence-based line under how concerned to be about further large shaking specifically from this fault segment. Issued in the days after the initial rupture, the forecast judged it likely that an aftershock above magnitude 5 would occur somewhere along the rupture zone within the following year, but only unlikely, though not impossible, that a much larger aftershock reaching magnitude 7 or beyond would follow. Based on the pattern of aftershocks recorded through early July, the sequence was actually running on the lower end of what a typical earthquake sequence this size would be expected to produce, with only about a 25% chance of a magnitude 6 or larger event within the following year. Then, on the 20th of July, new shaking hit the region again, and this time it struck Trinidad and Tobago directly rather than by distant transmission. 2 moderate earthquakes shook the islands within 70s, minutes of each other in the early morning hours. The first, a magnitude 5.0, struck at 6:55 in the morning, roughly 67 kilometers northwest of Port of Spain, at a depth of 80 kilometers. This one was, in seismological terms, entirely unremarkable, occurring inside a well-documented, historically very active zone north of the Paria Peninsula, where the South American plate descends into the mantle, and more than 1,400 earthquakes have been recorded within 20 kilometers of the spot. The second earthquake is the one that actually matters for the question this video is asking. Striking at 5:45 that same morning, a magnitude 5.1 earthquake hit roughly 6.5 kilometers northwest of Charlottesville, off Tobago's northeastern coast, at a depth of about 59 kilometers. According to the University of the West Indies Seismic Research Center's own analysis, this was the strongest earthquake ever recorded within 20 kilometers of that exact location in the entire instrumental record. Fewer than 100 earthquakes total have ever been logged in that specific 20-kilometer radius, and the location itself does not fall inside any of the 8 seismic zones researchers have mapped around Trinidad and Tobago based on where earthquakes there actually tend to cluster. This was not an aftershock of any known ongoing sequence. It happened in a genuinely quiet corner of the map. That quiet corner is precisely why some researchers have flagged this general stretch of the Caribbean-South American plate boundary running through the waters around Trinidad and Tobago as a locked segment, meaning the two plates are not sliding smoothly past each other the way the Los Bajos and Warm Springs faults typically do, but are instead sticking, building up stress that has nowhere to go except into a future, larger rupture. Researchers studying this configuration have described it as theoretically capable of producing a magnitude 8 earthquake, an order of magnitude more energetic than either half of the June doublet. This is genuinely worth taking seriously, and it is also worth being precise about what would distinguish an actual release of that specific locked segment from the kind of moderate, comparatively survivable earthquakes the region has experienced so far this summer. Depth is the single most important piece of that distinction, and it explains why the recent Tobago area earthquakes, despite their genuinely unusual location, have not caused injuries or significant damage, even though a similarly sized earthquake at a shallow depth absolutely could. Shallow earthquakes, generally defined as occurring less than about 70 kilometers below the surface, are responsible for the overwhelming majority of earthquake fatalities worldwide because their energy has far less distance to travel and dissipate before it reaches the surface and the structures built on it. The June Venezuela doublet struck at depths of just 10 and 27 kilometers, genuinely shallow, which is a major part of why it proved so catastrophic, despite occurring on land rather than offshore. The July 20th earthquake north of Tobago, by contrast, struck at a depth of roughly 59 to 73 kilometers, depending on which monitoring agency's estimate you use, deep enough that a comparable magnitude event produces markedly less violent shaking at the surface. A locked, shallow segment of plate boundary. Releasing in a genuine magnitude, 8 rupture would be expected to occur far shallower than that, closer to the surface, where the two plates are actually welded together rather than deep within the descending, already subducting slab of oceanic crust. There is also a longer historical baseline worth understanding here, because it puts both this summer's activity and the locked fault question into proper context, rather than treating either as unprecedented. Across the wider Eastern Caribbean, researchers have documented a fairly consistent historical pattern of major earthquakes in the magnitude 7 to 7.9 range, striking roughly every 20 to 30 years. That pattern has held reasonably well. The most recent major earthquake in that range struck north of Martinique back in 2007. Genuinely great earthquakes, magnitude 8 or larger, have historically occurred roughly once a century across the region, and the last one at that scale struck in 1843, which, by that historical spacing alone, means the region is arguably due, though seismologists are consistently clear that earthquake timing cannot actually be predicted with any precision using historical spacing alone. Separate research, specifically modeling recurrence intervals for the East Hispaniola and Puerto Rico trench fault systems, a different but related segment of the broader northeastern Caribbean plate boundary, estimated magnitude 7 events there recur roughly every 220 to 450 years, with magnitude 8 events recurring on a scale of 3,000 to 5,000 years, and put the maximum plausible magnitude for that specific fault system at around 8.2. It's also worth understanding that this recent stretch of activity is landing on a region whose actual monitoring capacity remains genuinely thin, a point the scientists doing this work have raised themselves rather than something being speculated about from outside. Much of the detailed analysis of exactly how Trinidad's coastline moved this summer relied on a single publicly accessible imagery, and geologists who physically traveled to affected sites and photographed what they found, rather than a dense, purpose-built regional monitoring network. Dr. Abayomi Osotui of the University of the West Indies Seismic Research Center has said publicly that earthquakes of this kind are broadly expected for the region, while also acknowledging that the monitoring network covering it still has considerable work ahead of it, with the center currently operating just one seismometer covering all of southwestern Trinidad. So, to actually answer the question in the title as honestly as the evidence allows, is the locked fault finally releasing? Based on everything currently known, the most accurate answer is that nobody can say for certain, and the specific evidence available right now does not point clearly in either direction. The June doublet that caused this summer's catastrophic damage occurred on the Venezuelan portion of this broader fault system, not on the specific locked segment near Trinidad and Tobago researchers have flagged as the greater long-term threat. The July 20th earthquake north of Tobago was genuinely unusual, striking a segment of ocean floor with almost no prior recorded seismicity, but its depth places it within the descending slab rather than on the shallow, welded interface where a true locked segment rupture would be expected to originate. What can be said with confidence is that the broader region remains under continued active stress following June's doublet, that the USGS's own Aftershock forecast leaves real, if statistically modest, room for a significantly larger event within the coming year, and that seismologists studying the area consider it entirely reasonable to expect further ground deformation, mud volcano activity, and moderate earthquakes across this stretch of coastline for the foreseeable future, regardless of whether the specific locked segment near Tobago is nearing its own separate rupture. So, what does all of this actually mean for you, particularly if you live anywhere across the Eastern Caribbean or have family there? It means understanding that earthquake risk in this region is not confined to the immediate area around any single epicenter. Since Trinidad's own coastline rearranged itself dramatically from an earthquake most residents never even felt. It means treating unusual seismicity in historically quiet areas, like the July 20th earthquake north of Tobago, as genuinely worth monitoring closely without assuming it automatically signals an imminent, catastrophic rupture, since depth and location both matter enormously to what a given earthquake is actually capable of producing at the surface. And it means recognizing that earthquake prediction, in the sense of specifying an exact time, location, and magnitude in advance, remains scientifically impossible, regardless of how much data researchers gather, which is exactly why the standard, practical advice, having an earthquake plan, knowing how to protect yourself when shaking starts, and not waiting for an official warning before moving away from vulnerable coastline, remains the single most useful thing anyone in the region can actually act on right now. The honest, grounded summary is this: Venezuela's twin June earthquakes have now killed more than 6,400 people and reshaped part of Trinidad's coastline from 780 kilometers away, entirely through long-period seismic waves that most residents never felt as a conventional earthquake at all. Weeks later, new shakings struck the islands directly, including an earthquake north of Tobago, unlike anything in that specific location's recorded history, landing on a stretch of plate. Boundaries some researchers have identified as locked and theoretically capable of a magnitude 8 rupture. But the current evidence, particularly the depth of that July earthquake, does not clearly show that locked segment releasing yet, and the region's own aftershock forecasting places only modest odds on a substantially larger event in the near term. What is certain is that this fault system remains active, understudied relative to its risk, and very much not finished with this summer. We are going to keep tracking this as the seismic picture develops, sourced the same way we did today, straight from the United States Geological Survey, the University of the West Indies Seismic Research Center. Indeed, the geologists actually walking these sites, not recycled headlines. Subscribe so you do not miss the next update, because based on everything we just walked through, this region is very likely to keep producing exactly this kind of story. And leave that comment below. Tell me if you have any connection to Trinidad, Tobago, or Venezuela yourself, because behind every one of these numbers is a family in La Guaira, still searching for someone the earthquake never returned. A farmer at Galfa Point, standing on a beach that rose 20 feet under his feet in a matter of seconds. And a seismologist right now, staring at a graph from one citizen-run instrument in north-central Trinidad, trying to work out whether the ground beneath an entire region is about to move again. 5,000 likes on this one. Let us go. See you in the next one.